Greetings, curious minds, and welcome to a captivating journey through the intricate world of neuroanatomy. In this enlightening YouTube lecture, we are delving deep into a topic of immense significance: ascending and descending pathways. I'm your guide in unraveling the mysteries of how sensory and motor information travels within our nervous system. So don't forget that ascending and descending pathways, also known as sensory and motor pathways, which transmits these information from the spinal cord to the brain and brain to the spinal cord. So let's embark on this adventure together. To understand the complexity of the nervous system, we must decipher the pathways that allow communication between our brain and the rest of our body. Ascending pathways transmit sensory information from our body to the brain, while descending pathways convey motor commands from the brain to our muscles and organs. These pathways, like intricate highways, play a pivotal role in our daily activities and sensations. Let's begin our exploration with the ascending pathways. These intricate networks of neurons relay sensory input, such as touch, temperature, pain, and proprioception, from our body to the brain. The spinal cord serves as a gateway for these pathways, with each ascending tract transmitting specific types of sensory information to different regions of the brain. The fascinating spinothalamic tract. So, we look that one of the star attractions of ascending pathways is the spinothalamic tract. Imagine it as a thoroughfare dedicated to transmitting pain and temperature sensations. This tract relays information from receptors in your skin and travels through the spinal cord to reach the thalamus and eventually the somatosensory cortex. This journey forms the basis of our perception of pain and temperature changes. Now, let's take a detour to explore the dorsal column medial lemniscus pathway. So, look at this picture this pathway as a high-speed rail system for transmitting touch and proprioceptive sensations. It involves a relay of information from receptors to the medulla, where the gracile and connate nuclei refine the signals. From there, it continues its ascent to the thalamus and finally to the sensory cortex, shaping our perception of touch and body position. We transition to descending pathways. The spotlight shifts to the brain's control over movement. Descending pathways initiate voluntary movements and regulate muscle tone, forming a crucial link between the brain and the body's execution of motor commands. So, meet the pyramidal pathway, a remarkable network responsible for executing skilled and precise voluntary movements. It originates from the primary motor cortex, descends through the brainstem's pyramids, and crosses over to the opposite side, ensuring contralateral control. This pathway orchestrates our ability to perform intricate actions such as writing, dancing, and playing musical instruments. Our exploration would not be complete without a glimpse into the extrapyramidal pathways. These networks operate in parallel with the pyramidal pathway and play a role in regulating posture, balance, and involuntary movements. Dysfunction in these pathways can lead to conditions like Parkinson's disease and other movement disorders. The world of ascending and descending pathways offers invaluable clinical sites. Lesions or disruptions in these pathways can result in sensory deficits, motor impairments, and coordination issues. Understanding these pathways aids medical professionals in diagnosing and treating various neurological conditions. In closing, the intricacies of ascending and descending pathways remind us of the awe-inspiring complexity of our nervous system. From the spine to the brain, from sensation to movement, every pathway we have explored paints a vivid picture of the human experience. Thank you for joining me on this useful topic of the neuroanatomy, that is the ascending and descending pathways.